Okay, you're with Professor G, uh, working on marketing analytics with R. Uh, the next statistical test that we're going to discuss today is t-test. Let's take a look at some of the properties related to t-test. T-test actually helps a research to compare the means within or between sample groups. So it could be a single one group, or it could be two groups. Here, the t-test is used to test the difference of the means, or significance of the means. That's what we're going to do. So this is a parametric test. Like I have mentioned in my previous video clips uh, about the statistical test, parametric test helps a researcher to uh, do statistics based on a sample data set, and then based on that, statistics that you try to estimate population parameters. So you're trying to generalize your findings to the entire population, or bigger market in marketing terms. That's the process that we use when you do t-test. Step number one, you have to check for normality. This is one of the critical assumptions, I would say, in testing. You have to establish the normality. So you first you have to check the variables that you're going to use for the t-test are normally distributed. How do you do that? You can visually see using box plots, histograms, and things like that. Also, you can see numerically by using the describe function in the site package, and it will tell you the level of skewness. That's where we're going to focus more to understand the normality. Then, of course, step number two, you have to state the hypothesis. Couple of things we need to remember if you're dealing with one sample t-test. It's a single sample t-test. Your null hypothesis is going to be the true mean within the group is 0. There's no difference. That's what we say. The group means is going to be equal to 0. Your alternative hypothesis is going to be for the same single sample or one sample t-test is going to be the true mean within the group does not equal to 0, right? If you're using two populations, or two samples rather, to test the difference, the mean significant difference, we set the null hypothesis as there is no difference between the true means of the groups, or between the groups. That's how we set the null hypothesis. The alternative hypothesis for the two sample t-test would be there is a significant difference between the true means of the groups. There's another type of t-test that we do. We call that paired sample t-test. Now, what is paired sample t-test? Paired sample is used when there's some investigation that you want to see before and after. Say, for example, in terms of marketing, you want to see the mean sales value, or spend value, or transaction values before a customer receives the promotional material or promotional or direct email or something like that, and after the promotional material received or email received. So how the mean difference is established between prior and post kind of thing. That's what you look at. So that's where the paired samples are used. Now, when you do a paired sample t-test, the null hypothesis is going to be there is no difference between prior and post means of the groups. could be means of the income. It could be means of the customer purchases. It could be means of the levels of the customer spend. Any continuous variable, right? And step number 3 is going to be set the P cutoff value. Now, in all my classes, the standard P cutoff value that I set is 0.05, which is 5%. So that's going to be standard thing that I'm using in all my classes. Step number 4 over here, it should be step number 4. I'm so sorry about that typo. Run the test. You have to run the t-test, and then step number 5, you need to interpret the results. Finally, also I would like to share with you how to conduct a kind of a t-test in the form of a function in R, like using the tilde function. This is the tilde function. This is the response variable, the y variable, dependent variable, and this is the predictor variable, or we call it x variable or independent variable. So let's look at how you do that one. What I'm going to do now is step 1, check for normalities. That's what we're going to do. First thing first, let's import the data set to the R console, R Studio rather. So I'm going to use this external website to import the data set, and I'm going to name it as underscore seg. That means customer segmentation, customer segment data set. So I run that. Now I have the data set imported. I want to just do the initial inspections. What I'm going to do is I'm going to do head of the customer data set, and that's how I see it has age variable, gender variable, income variable, kids, age of the customer, gender of the customer, income, number of kids, whether the ownership of the house, whether the customer subscribes or not, and which segment that customer belongs to. So I want to take a look at from the bottom of the data set. So using the tail function, let's take a look at that one. I do not see any missing values. We are good over there. I want to look at the structure of the data set by using this str function. Let's run that one. This will tell us everything about the structure of the object or the data set. Not the object. This has 300 observations and 7 variables. The first variable, age, is a numerical variable. Gender is a character, or we call it categorical. Income is a numerical variable. Kids is an integer, whether you have how many kids, 1, 2, 3, 4, whatever. And then the home ownership is also a categorical or character variable, whether you have or not, yes or no. Then you have the subscription, yes to subscription, no to subscription. These are the 2 levels that you find. It's also a categorical variable or character variable. The last one is also character variable, categorical variable, that indicates what is the name of the segment that customer belongs to. Okay, let's try to understand the income. That's what we're going to use. So let's use the income variable. I am going to say, let's check the normality of that. Normality check. So I'm going to say customer. Let's do the visualization to that. Let's say box plot box plot of the customer segment data set. I'm going to use the $sign to specifically look into the income variable from that data set. Let's run that one. And you can see in the plotting area onto your right bottom part, it looks good to me so far, but this is only a visual inspection that we are making. Therefore, we need to take a look at from a different angle perspective as well by using histogram. Let's use histogram to customer segment data set on the income variable. Um, yeah, it looks normally distributed, but slightly kind of some anomalies existing, I guess. Therefore, our visual inspection does not tell us exactly whether this is normally distributed or not. We have some suspicion here. So what I'm going to do is we are going to use a numerical inspection. For that, we are going to install psych package, which I have already installed that one. Therefore, I'm going to load the package by calling the library function. Library function, I'm going to call psy psych, and then I'm going to run that one. If you do not have installed that one, you have to first install that one. So I'm ready loaded with the psych package. Why I did that is because our visual inspection did not help us to understand whether this is normally distributed or not. Therefore, I'm going to use the describe function in the psych package to understand numerically whether this income variable is normally distributed. So customer data set, segment data set, I'm going to pick the income. Now in the console you can see this is the number of variable 1 and number of observation 300. The mean value of this variable, which is the income variable, is that this is the standard deviation of the income. Excuse me. This is the median, trim value, so on and so forth. And then what I'm really interested in is the skew. Now let me talk about that a little bit. We use a rule of thumb when you determine whether a data set is, or whether a variable is normally distributed or not. Excuse me. By checking the number of the value of the skewness. Now the rule of thumb says any value minus 0.5 and any value that falls within minus 0.5 and plus 0.5 can be taken as normally distributed. Now if you look at this skewness over here, 0.14, which falls within that range that I specified earlier. This falls between the minus 0.5 and plus 0.5. Therefore, based on the rule of thumb, I'm going to assume this variable to be a normally distributed variable. So we are good with the first one. Now we are moving into the second step in the entire process. What we're going to do is we are going to set a null hypothesis for the one sample t-test. So let's do that one. One sample t-test. So let's do the null hypothesis. I'm going to say null. This time I'm going to say our null is going to be the true mean is equal to 0. 0. So let's test this one by using the t-test function. I'm going to say, as we know, we have already set the cutoff p-value for the cutoff point. P-value cutoff is going to be 0.05, and let's run the test now. That is t.test customer, oh yeah, customer segmentation, the income variable. We are trying to establish if the mean value is 0 or not. Let's take a look at it. So if I run this one, you will see that in the console it produces the outcome of the test, one sample t-test, because we are using only one sample. We're trying to understand within the one sample, that sample, if the mean value is equal to 0. So you can see the t value is over here, and the degree of freedom 299. That means n minus 1. 300 is the total number of observation, minus 1 is 299. The p-value is produced as an exponent. In other words, 2.2 times 10 to the power of minus 16. That is way lower than the cutoff point that we set. So it's less than 0.05. When the p-value is low, the null must go. So in other words, the null is rejected. True mean is equal to 0. Actually, we are in support of the alternative hypothesis, which is the true mean is not equal to 0. That's what the p-value established here. Now, a couple of things that I want to explain in this outcome. The alternative hypothesis is also mentioned here. True mean is not equal to 0. That's what it says. So, and the other one is 95% confidence interval. When you say 95% confidence interval, it does not tell about the confidence level, your personal confidence level, or the researcher's personal confidence level. It means that if you run the same test with the same sample size 400 times, you will see 95 times this value, the mean value of that variable, will fall anywhere between these two values. This is the confidence interval. This is the lower bound, while this is the upper bound. So this value that we got, a sample estimate of the mean of x right here, is between these two values. So that's what it says. So if the value that we got falls within the confidence interval levels, then we actually reject the null hypothesis. If it falls beyond these two boundaries that we set as confidence interval, it will be the null hypothesis will be accepted. So that is how you do a a t-test. Now, as I was talking about the two sample t-test, let's try to understand that as well. Let's do two sample t-test. What we do here is we are trying to compare the means of both groups. That's what we're going to say. So the argument, null hypothesis that we're going to set here is the true mean of these two groups are equal. That's what we are trying to say. Oh, no difference. There's no difference in that. That's the argument that we're going to set. So in this case, since I am not going to use the same data set, I want to create two variables, two vectors, I would say. So let's say we have one group that says the level of customer satisfaction on a scale 1 to 100. Say so I'm going to say a combine function and say give me, I'm going to create, I'm creating a sequence here. This is the level of customer satisfaction of one group. So I'm going to say customer dot satisfaction one, group one, and that's how I'm going to save this object, data object, which has whatever these customers said in terms of their level of satisfaction on a scale 1 to 100. Okay, so I'm going to run that one. When I run that one, you will see that it is created on this side. It is created on this side, customer satisfaction one. So that's a customer first group. Let's create another group. I'm going to say customer dot satisfaction, this time let's say second group 2, and I'm going to say anywhere that they said between 101 and 200. Okay, so I want to find out let's set the null hypothesis here. What's going to be our null hypothesis? Now I'm going to say based on my null hypothesis, the true difference in means is equal to 0. That's what I'm going to say. The true difference is equal to 0. That means, in other words, we can say that there's no difference between the true means of these two groups. So I'm going to say there is no difference of the true means between the groups. So that's how I'm going to say that. Now we are going to run the two sample t-tests. So I'm gonna say t-test t.test, and then I'm going to bring the customers dot sat1 comma sat2. So these are the two groups that we administered a survey hypothetically for this scenario. I'm trying to use that one. The first group is customer satisfaction 1. Second group is customer satisfaction 2. On two different scales, they have indicated the level of customer satisfaction. So that's what I'm trying to say between these 100 customers. So let's see if the mean values are equal or different. So I'm going to run this one. So if you look at this one, I'm going to jump right away onto the p-value. It says 2. This is an exponent. So it says 2.2 times 10 to the power of minus 16, which is less than the cutoff point, which is 0.05. As a result, when the p is low, the null must go. That's a rhyme I have practice. So the null says there is no difference of the true means between the groups. Actually, based on the p-value, we reject the null. Therefore, we can argue that there is a difference between the true means between the groups. That's what we can argue. So we are going in support of excuse me, the alternative hypothesis. True difference in the means is not equal to 0. they are different. That's what it says. So the 95% confidence interval is minus 108 to minus 91. So anywhere is there could be these uh, these values. So if you look at this first one, means of the first one, 50, which falls between these two. Uh, so I'm sorry. So you can see the difference between these two. So the mean values are different between the two groups. That's the argument that we are setting here. Uh, Anything else I want to say here? So this is a two sample t-test, and based on the p-value, we reject the null hypothesis. Yeah. Okay, let's move on to the other one. The other thing that I was talking about, if you can remember, is that the paired sample t-test, which is the third one. We looked at the one sample t-test, two groups or two sample t-tests, and now we're going to look at the paired sample t-test. Let's look at that one. So let's take some space there. Okay, for this paired sample t-test, actually, as I said, it investigates the prior and the post mean difference. So I'm going to type that this is paired t-test. What it does is actually it investigates the prior and post mean difference. That's what we are going to look at. So let's create two random samples before and after sales promotion campaign. So the context is going to be a company is using a sales promotion campaign, and they want to measure if the excuse me, mean sales that they got before and after the sales promotional campaign was run or the use, how much that was, whether that is different or whether there's no difference in this. So what we're going to do is we're going to create a new random variables. First one, I'm going to call it as sales dot promotion dot before. Where am I typing? It should be actually coming over here. And let's save it as that. What exactly we want to save is I'm going to create a random variable by using the function called run if. So I'm going to say run if, and then I'm going to say give me 50. That's the n equal 50. Give me 50 numbers. Minimum equals let's say minimum equals 25, and maximum equals let's say 350. So I'm going to create that one as the new vector, new variable, random variable that has 50 customers who purchased minimum 25 and maximum 350. So I created that one. Now I'm going to call that and see how it looks like. This is how we see what the customer said hypothetically. All these respondents said, these are the values. These are our sales. That this is how much we bought after before the sales promotion campaign was run. Now let's create another variable uh, to measure the after effect. So I'm going to say sales dot promotion dot after aft, and then we'll save. We'll use that to save our next variable, random variable that we're going to create. Run if the same function I'm going to use, and then I'm going to say run if n equals 50, same number of customers. This time minimum equals say 5, and maximum equals 330. The reason why I'm creating this one is because I do not have a data set at hand for me to refer to two variables after and before, kind of thing, or prior or post. Therefore, I am hypothetically creating two random variables to demonstrate how to do this one paired sample t-test kind of thing. So I'm going to run this one. Created. Now let's check that as well. So I'm going to I'm a lazy person. I'm going to copy this one and paste here, and then I'm going to run that one. This is what they have done after the sales promotion, right? This is before the sales promotion, and this is after the sales promotion. Same number of customers before and after. That's the only difference. It is the same number of customers, same customers, 50 customers. What they bought from, how much they spent on purchases before the company runs the promotional campaign and after. That's what I'm trying to say here. Okay, now let's run the paired t-test. Now, how do you do that? Now, before we run that one, we need to set the null hypothesis. I'm going to say null is going to be true difference, or true difference in means equal to 0. That's what our argument is going to be. That's what we're going to test, actually. That's the right technical thing to say. Okay, let's run that one. I'm going to say t-test. This time we are going to say sales promo before, comma, I'm going to say sales promo after, and this time we are going to specify the type of the test that we want to say. Here I'm going to say paired equals to true. You can say TRUE or the full, all the letters, or just you can say T. I'm going to say true, and I'm going to run this one. Now you can see I'm going to straight away look at the t-value, standard deviation, degree of freedom, rather, the p-value. This is what is important for me. The p-value this time is greater than 0.05. The p-value that we have yielded is 0.90, way higher than 0.05. As you see this one, first thing that you need to do is we need to say that there's enough evidence, statistical evidence, to accept the null hypothesis. Now, what is the null hypothesis? True difference in means equal to 0. That means there is no difference between running the campaign prior to the running the sales promotion campaign and after the sales promotion campaign in terms of the mean value of the sales that they did for the company, or the mean value of customer purchases. That's what it says. So there's no difference in that. So this tells us to a marketing manager, your sales promotion is not effective. So you can make decisions based on this kind of test. Okay, the last thing that we're going to look at is how to do a t-test as a function. Now, as a function, I'm going to say as a function, t-test as a function. Using the tilde function. Oops. That's what we're going to use. So our response is going to be the y, and our predictor is going to be the x. So that's how you create the function. So what I'm going to do is I'm going to say t-test. I'm going to say this time I want to see the difference in terms of income of the gender, comma, I have to specify the data set. So data equals customer segment, all the way down customer seg. That's our original data set that we've been using. So if I run this one, I'm happy, I'm glad there's no errors or anything like that. You can see that the hypothesis that we set, like previous attempt that we did, the income, there's no difference actually. That's the null hypothesis. There's no difference of the average income based on the gender. That's the null hypothesis. Let me write that also. Null is going to be, there is no difference of the average income between the gender. All right, so that's what we want to say. So if you run this one, you will see that the p-value is higher than 0.05. Now here 0.08. That means we have to accept the null hypothesis. What our null hypothesis? There is no difference of the average income between the genders. Let's take a look at the gender variable here. Let's look at gender variable here. Customer segment data set gender. Let's table this one, then we can see a clearer picture. If you table this one, you will see there are 157 females and 143 males. So between these, the average income, there's no difference between these. That's what it says because of the p-value. The p-value is greater than 0.05. So we are not going to go in favor of the alternative hypothesis, that is true differences in means between the group female is not equal to 0, right? So that is what we are trying to say here. So when so we have to accept the null hypothesis here. So that's how you see, that's how you do a t-test as a function to test the difference. Now here in this function, we are trying to predict the income of the by the gender. That's what we did. I hope this is clear and you will enjoy this one. I am looking forward to do another short video on analyzing the differences when there are more than two groups. When there's single group, we use t-test. When there are two groups, we use two sample t-tests. When there are three and more, we need to use the analysis of variance ANOVA. That is the test that we're going to do. So I will come back to you with that quick video very soon. Until then, bye now.